So my IPCV presentation topic is morphological processing. What is morphological processing? It is linguistic and computational technique used to analyze and structure and form of words at a morpheme level in NLP. A morpheme is smallest unit of language that carries meanings. It also involves breaking down words into morphemes and understanding their grammatical and semantic roles within a word. So these are types of morphological operations. First is deletion. In this process, we add pixels to the bounded objects. The highest value of all the pixels in the vicinity makes up the output pixels value. A pixel in a binary image is set to 1 if adjacent pixels have a value of 1. Morphological deletion fills up small gaps in objects and increase object visibility. So some of the important properties of deletion are as follows. It can mend damages, it can correct encroachments. Second operation is erosion. In this process, we remove pixels from the edges of the objects. The lowest value of all the neighborhoods pixel make up the output pixels value. Floating pixels and thin lines are eliminated through morphological erosion, leaving only substantial objects. Some of the important properties of erosion are as follows. It can disassemble the joint objects. It can remove extrusions. Then what are the key aspects of morphological processing? First is morpheme identification. It identifying morphemes within words by analyzing prefixes, suffixes, roots, and other morphological components that convey meaning or grammatical information. Second is stemming and lemmatization. Stemming is a process of reducing words to their root or stem form, typically by removing suffixes. And lemmatation involves determining the base or dictionary form of a word, considering its part of speech and context. Third is affix stripping, separating prefixes and suffixes from words to isolate the base or stem, adding in understanding words, variation, and meaning. Fourth is word formation rules, applying rules to generate new words by combining morphemes, understanding derivational and inflectional affixes, and their impacts on word meaning and form. Now comes the advantages of morphological processing. First is improved language understanding. Um, in this understanding, the morphological structure of words helps in deciphering word meanings, enhancing overall language comprehension. It enables machines to interpret nuances and subtleties in language uses. Second is lemmatization and stemming. Lemmatization and stemming reduce words to their base or root forms, reducing vocabulary size and simplifying analysis. Then third is efficient information retrieval. Morphological analysis helps in indexing and retrieving information more efficiently. Variation of a word's morphological forms can be grouped under a common root, improving search and retrieval accuracy. Fourth is text normalization. Morphological processing helps in normalizing text by converting words to a standardized form. This standardization ensures consistency and accuracy in various NLP applications such as spell checking and information retrieval. Machine translation. Understanding morphological structure of words is crucial in machine translation, especially for languages with complex morphological rules. It aids in producing accurate translations by considering morphemes and their meanings. Now, disadvantages of morphological processing. First is ambiguity and complexity. Morphological analysis can be complex, especially in language with intricate morphological rules and high levels of ambiguity. Identifying and assigning correct morphemes and meanings can be challenging. Second is languages with irregular morphology. Some languages have irregular morphological patterns, making it difficult to create general rules for morphological analysis. This hinders effectiveness of automated morphological processing. Third is out of vocabulary words. Morphological analyzers may struggle with out of vocabulary words, neologisms, or specialized terminology that do not conform to standard morphological patterns, leading to incorrect analysis or inability to process. Computational resource intensiveness. Performing morphological analysis or large volume of text or in real time applications can be computationally intensive, impacting processing speed and resource usage. Fifth is overstemming and understemming. Stemming algorithms may sometimes overstem or understem, resulting in incorrect root forms and potentially impacting downstream NLP tasks. So here are the applications of morphological processing. NLP systems use morphological analysis to understand the structure and meaning of words. This is for tasks such as part of speech tagging, stemming, lemmatization, and entity recognition. This analysis can aid in translation tasks by breaking down words into morphemes and translating each morpheme individually, which can be especially helpful in morphological rich languages. Morphological processing can aid in sentiment analysis by breaking down words in morphemes and analyzing the sentiment of each morpheme, providing a more granular understanding. The text overall sentiment. Morphological processing is used to expand search queries by generating variants of original query through morphological transformations to improve search results. So this is what the morphological processing is, and thank you.